Hello, Rick. I'm going to go over this Microsoft Excel-based golf hole simulator. It's got a couple of input worksheets. It's got this one. It's got another one with some parameters. Once everything's inputted, you hit this simulate button, and it runs a series of Visual Basic code, and it generates output here. So let's go through it real quick, and I'll give you an idea of what this model is supposed to do. So probably the first input is this footprint is where you can design a golf hole. The tee box is always here. The green can be anywhere you want. Right now, here's where the green is. The flag stick's right there in this one. So each of these coordinates are 10 yards by 10 yards. It doesn't get any more detailed than that. And how you change the values is you put in these numbers. So if I wanted to put some water across right there, I would type in an 8. And I could put a stream across like that. If I wanted to take the green and move it out here, I could. And then I could do something like that. So now I've turned this hole into a 530-yard hole. Yeah, you can do whatever you want. You got your tee box, you got the green and the flag stick. The dark green is fairway. The light green is rough. If I wanted to put a bunker somewhere, type of 6, there's a bunker. The trees are brown. Water's blue. And the concept on this is when you hit a ball, when a ball is hit, it's always its ability to be accurate and how far it can hit is a function of the golfer's ability and the lie. So if you're hitting from the fairway, you're going to have a chance to hit it further and more accurate than if you're hitting from the rough. And the best thing is when it's on a tee. So the tee is kind of like the very best. You're most accurate when the ball's sitting on a peg. You're least accurate when you're sitting somewhere that's not that. So it always goes down from that. This little line here, you decide that's a target. This is how the logic, the way the model works, is that becomes the target if you can't reach the green. So the general rule, the general logic that is written into this simulation is that the target is always the flag. But if you can't reach that, for example, they can't reach that from the tee box, then there's some looping or iterative logic that moves back on the target line to something that's reachable. So if I have someone who can hit the ball 250 yards, then the target's going to be there because that's 250 yards away. And you can see this is the last run of the model. This is where one of the shots went. And I'm going to go ahead and I'm going to hit the simulate button since I've changed this now, and I'm going to run it real quick. It takes about a minute to run, so when I hit simulate, I'm going to go ahead and stop the video until it comes back up and running. Okay, that took a little bit less than a minute, but you can see now here's where it started, and with this redesign, this is where all of the golf balls went. And they do things different, or it's just like playing golf. When you're hitting from the fairway, the likelihood that you can hit where you want after that is higher than when you're in the rough. And when you hit into the trees, then it's kind of a crapshoot that there's a good chance that your ball is going to go very short or go backwards or go sideways, so that can happen. So this is playing the golf hole a whole bunch of times, and this is where the golf balls went. Now, some of the weakness to this is that this is the only footprint, so it's only 100 yards wide. So you can see that there are times that I went right to the edge of my footprint, and it may want to go further. Right now I don't have the ability to model that. So this is the output. After I change this, hit input, this is the output. Let's go over and look at some of the parameters that we have control over. One of the things that we do is that there is, based on the lie, again, green, tee, target, rough, sand, water. These are the impacts of that. So there is a scaling factor. The highest number is 1, and then it goes down. For example, if you can hit a ball 300 yards off the tee, then and when you're hitting from the fairway or target, then the most you can hit, the maximum distance is 90% of 300 or 270 yards. Hitting from the rough, it goes down more. Hitting from the sand, it goes down more. So we can control whatever these numbers are. We have control. If we want to say the rough is really thick, you like US Open thick, we can make that 0.5. And now that means that when you hit in the rough, then the furthest you can advance it is half of your max distance. So this is distance scaling factor. Now distance accuracy. So if I'm trying to hit a ball 100 yards and I might hit it more than 100 or less than 100. That's what this does. And this scale factor, 1 is the best. And then when it gets bigger, that means there's a chance I can be long or short more often. Same thing you can see from the rough, I might catch a flyer. From the bunker, I might catch it thin. So they're bigger there than they are with these other ones. Then the accuracy, think of an angle where I'm trying to hit a ball at a certain target. So if I'm here, and if I'm trying to hit it there, that angle from this to this, if there's a deviation left or right, there's an angle to that. And that angle gets bigger, or this scaling factor gets bigger based on if it's the lie. There is a time scale factor, so how long it takes to do something based on the lie of the ball, is there an impact on that? And you can see when you're in the rough, it takes longer to address the ball. Same thing on a bunker. Again, you can change these numbers to whatever we want, and that'll impact the time. And then also a percentage of lost balls. So if you hit a ball in the rough, there's a 1% chance you're not going to find it. If you hit in the trees, hit in the water, you're guaranteed not to find it. So these are inputs. These are all these scaling factors. There's also the time, how fast that you move down if you're walking versus in a cart. Right now, I've got it set up where people walk 3.8 miles per hour and a cart goes 9.2. Finding a lost ball, the average time in seconds is a minute and a half with some standard deviation. I think the max you can look is 3 minutes. So we probably ought to change this to make that number a little bit bigger. This is the time it takes to address the ball and hit it. The average is 40 seconds. Again, we have control over these numbers, and this is the distribution of the time to address and hit a ball. These are the type of golfers that we put on the course. Right now, I've got a bunch of good golfers. And what that means is that the planned max distance is 300 yards and the accuracy coefficient of variation is 5%. So my accuracy, it's more accurate than these people. You put some information here. These are calculations, but if you wanted to make this a par 5, you certainly could. It's 535. It probably should be a par 5 for most people. You can go put different types of golfers on here. So if I wanted to make this a public play, maybe this is what I have more realistic, where I've got a bunch of beginners, a range of this, and then a handful of really good golfers. And anytime you change this, then you can go rerun it. So I'm going to rerun it again and see, now that I've changed the makeup of golfers on this, and I rerun this, again, I'm going to pause the video as I'm running because it takes about 30 seconds to run. And you can see that now with the bunch of golfers, they're all over the place. There's a lot in the water, which means they got to go no closer to the hole, away from the water to hit. A lot of mess, a lot of happen. And we'll look at this last, but it also impacts how long it takes to play, the time it takes to play that hole. So back to the inputs. We have the scale factors, we have travel times, we have finding a ball or hitting times. We've got the makeup of the golfers and their ability, so all of these are inputs. Anything that's grayed out like that is an output, but everything else is an input. We can put in how fast the greens are. This is something that definitely needs to be worked on. So when they are on a tee or on the green, what I do is I use a multiple regression model, and I randomly generate how long that they're on the green or tee as a function. If we're talking about putting, it's a function of green size, green speed. Is it a par 4 or par 5? Wind speed. That's what the number of golfers is definitely probably the biggest one. On the tee box, it's a function of number of golfers, and that's it. We need to redo the regressions, and these become the regression coefficients. So this is a separate study to determine how long people are on greens as a function of anything that we want it to be, and how long they're on the tee box, because this particular model is really more about the time it takes to move from the tee box to the green as a function of features and ability and these parameters. Okay, so those are the inputs. That's it. You design your hole, you put these in, and then when you run the model, and let's get it back to some good golfers here. Let me put this back to some good golfers. Like that. And let me run the model again. Okay, so I've rerun the model, and you can see there's much better accuracy. But anyway, we changed the course. We can change it to whatever we want. We can change the inputs, and then when you run the model, then we can look at the output. So let's look at what happens. What the model calculates, it knows the fairway hit percentage, the GIRs, greens in regulation, average driving distance, how many times I hit in a bunker, water, how many times I lost a ball, the ability of my golfers, my strokes to green. I had 9% reach this par 5 in 2. Most of them got there in 3. There were some that got there later than that. And then, based on where the ball is, then are they playing where they're walking? Are they playing as a single, a twosome? Actually, I don't think I have singles. But now what I can do is I can repackage and put things together. So this is how long it takes a twosome. This particular group of golfers, a twosome, to play this hole is about 16 minutes. I've got a standard deviation. I've got a breakdown on how long they're spending on the tee box, fairway, or excuse me, the tee to green time and the green time. And these total to this number with some measure of variability. And then if you put a threesome, you put people in carts. Carts 90-degree rule, carts cart path only, which is a combination of walking and carts. All of this then, and then we can draw pictures of what these shapes are. So the red is the threesome walking. You can see it's averaging about a little over, what is that, probably 11 or 12 minutes for a threesome walking. Actually, it's much wider than that because you got this thing here sitting there. So anyway, this is the type of distributions that we get. Again, you get these additional humps here to the side because of crazy things that happen, but that's what golf is about. And you'll lose a ball, and all of a sudden that happened enough that's what happened. So this is the distribution of times of how long it took to play a hole for these different types of groups. So that's what this model is about. This model allows us to take golfer ability, all kinds of inputs, course design, and then what it generates is how long it takes to play that particular hole. It is not a series of golf holes, it's just one golf hole. So there's no queuing other than the time within a group. So this is the model. We need to get it validated, which means we need to pick some golf holes that we can go collect times on them and then make the model change these parameters, all of these parameters, so that our results reflect what happens in real, and then we have a validated model, and then that's what we can publish. So that's what I'm wanting to do, and I hope it makes sense. After you've watched this video and played around with the model a little bit, let's meet and talk about our next steps. Thanks. Have a good Thanksgiving.